Hello, I'm Lori Chappell. I'm here in place of Al Tadros, who couldn't make it today. Al sends his regrets. I'm sure many of you know him. I'm from Space Systems Loral, which is across the highway in Palo Alto, so we're just down the street from here. We make very large geostationary communication satellites, like 6,000 kilograms. So you may wonder why we're here at a lunar CubeSat conference. But what I want to talk to you about today is Rideshare to GTO or GEO. So why we're interested in you guys instead of the typical CubeSat crowd is that you guys want to go beyond LEO. So in terms of Rideshare, we talk to a lot of CubeSat providers who are almost scared to go beyond LEO. You guys aren't. So in terms of Rideshare, where we go 6 to 8 times a year to GTO or GEO, you guys are the ones we want to talk about. Or talk to you. How do I advance my slide? Ah, here we go. So cost-effective, frequent, quick access to GTO. We often have a volume on our satellites that can accommodate a approximately 90 kilogram or 150 kilogram package, and that's a standard sizing that is frequently available. We do launch 6 to 8 satellites per year. We have right now this year 7 satellites already on order. In 2014, those will launch in 2016, so that 6 to 8 number is holding. So the point of this is that often the CubeSat community wants frequent launch opportunities because you want to launch something, then you want to try it again. So 5 times a year instead of once every 5 years is what I'm hearing from the community, and we can offer that. We are contracting for this right now, so the primary payloads are the giant ComSats are excited about this. Some people seem concerned that the primaries aren't excited. They are, because they want a price break. So we are contracting this right now. So the first example of this is going to happen in November 2016, and then frequently after that. Where am I pointing this towards to change? Okay. This I've talked a little bit about already. Our bread and butter is the large communication satellites. We've launched over 250. We have about 75 in space right now. In terms of having a secondary payload or a hosted payload, this isn't a new thing for us. This shows some of the hosted payloads that we've done previously. We've done about 14 hosted payloads, so that's where we attach a small satellite mission to our large satellite, but instead of it being dispensed and going on its way, it stays behind. So the question of do we know how to take another satellite and integrate it to ours? Yes, we've done it 14 times, and we have more in the works. The difference here is that your small satellite would be dispensed from our large satellite. This is independent analysis of forecast that shows the launch rate of vehicles. So I can keep telling you there's 6 to 8 per year, but these people who are independent corroborate that story in case you think I'm blowing smoke. So how we do this is a bit different than some Rideshares. We actually integrate your small satellite to our large satellites. So instead of being attached to the rocket itself, you would bring your satellite to our facility in Palo Alto, and we integrate it either deep into a spare battery bay, which is shown here. Often we don't need all the batteries that we have, so deep into the spacecraft there's a compartment that we can fill, or there's some mid-panel locations where we can put your satellite. We can fill up this battery bay with CubeSat dispensers. So there's many locations that we've identified as standard locations on our spacecraft that we integrate your spacecraft to ours and then dispense in the appropriate orbit, whether it's GTO, GEO. A concept that we're working with DARPA to create is commercial resupply of servicing infrastructure in GEO. So this is an example of us taking a small satellite to, this is near GEO orbit, dropping it off. We go to our orbital slot and start beaming your Super Bowl TV or whatever it is you want to watch. And this, the small satellite goes off and is retrieved by a servicing vehicle to do satellite servicing or resupply. So that's the mission concept we're working on with DARPA right now. For you guys more interested in going to the moon, a concept could be that we integrate your satellite to ours and then drop you off in GTO. Maybe it's favorable from a Delta V point of view to get dropped off in GTO rather than GEO. You get dropped off and then continue your mission onto the moon. So those are the kind of things we're looking at. We do use a variety of launch vehicles. They're shown there. Our last two launches were Ariane 5, and before that we had two Falcon 9 this year. So those are what tends to be trending right now. What's shown here is that if you want to get out in GEO, we can drop you in a sub-GEO or super GEO orbit. Some CubeSat developers are concerned about if their CubeSat is non-functioning when you get to orbit. They don't want to start cluttering up the GEO belt with dead satellites. So some people are happy to be dropped in the graveyard orbit. Just get dropped off there. If the CubeSat works, great, do your mission. If it doesn't, it's already disposed of anyway. People like that. But we do have a bunch of orbits that we achieve on our way to our orbital slot in GEO. So we can work with you to, say, get past the radiation belts or get to a favorable orbit for you. Power and data interfaces are available for the satellite, so we can provide resources to your satellite as you get to orbit. For DARPA, we developed a dispenser for their payload that was, because it was recessed deep in our spacecraft, they wanted it to be pushed out like a drawer out of their spacecraft. So we are working to develop this for, say, a 80-kilogram satellite. But what you could also do is use any of your favorite CubeSat dispensers and load up the volume that we have open on our spacecraft, load it up with your favorite CubeSat dispensers and a sequencer, and just deploy smaller, like 12U, 6U, 3U CubeSats from that space we have available. There are considerations that we need to take into account that you guys are all used to. This is an educated group, so I'm not going to go through this, but dynamics, RF, the thermal environment, and the INT flow, like where your spacecraft will show up in our integration flow, all need to be considered. We typically launch 24 to 30 months from the day we sign a contract. So you don't necessarily have to come on board at that 30-month point in time, but somewhere around the 24, 20-month point in time, we'd like to know you're around and have you signed up. That's a good baseline. We do have a whole bunch of services we can provide, so depending on what you need versus what, say if you're working with an integrator, the integrator may provide some of those services, but we can provide a lot of services to you in addition to launching, such as ITAR paperwork or things like that. I put in here details for the techies. You guys can look at it later when the slides are available online, but it shows a standard sizing, a standard mass. So these are things that are extremely frequently available on our launches. It's not to say that, and why there's a big circle here, it's not to say you couldn't launch any other sides. We're doing a 1,000-kilogram Rideshare coming up. But if you want that 6 to 8 opportunities per year, this is the sizing we're trying to hit. So that's a summary. We're going 6 to 8 times per year. We're signing up people now. We welcome any input from the users as what would be useful to make this a better, more attractive service to you. And come talk to us. We're just across the road.
Could you comment on what kind of requirements you would impose on, let's say, not so much the hosted payload, but let's say the CubeSat, in terms of all the typical space requirements, whether it be documentation, configuration control, software, the whole quality assurance, space mission assurance. We work on NASA programs, and that is actually the whole, through the life cycle, is a lot more than actually the hardware development cost. I mean, just so it turns out. And that paradigm is not going to work probably for all the CubeSat and even maybe the SmallSat. What is your plan? What is your vision? What do you see?
Certainly it's a do no harm paradigm. So this is harsh, but we don't care if your CubeSat works. We just don't want it to wreck the spacecraft. So I think it would be similar to any launch vehicle. Just you would need paper that gives proof that you're going to do no harm to the launch vehicle or to our satellite.
I'm pretty sure it's not just paper. It's probably a lot more requirements. So, could you
the review process? Do you have like some kind of a manual for like Class D review, passing at some level in terms of the normal review cycles for Class D?
Like a list of paperwork that we would need to see.
That you sort of check out that you've passed these reviews.
Yeah. But what I'm trying to say is I don't think it's different from any other rideshare you're going to see.
Thank you.
Yeah, I have a question. GTO initially could have a low perigee, and I just wonder if it's possible to do a maneuver to raise that before you dispense something.
Yeah, so I think still haven't figured out where I'm pointing this to make it go back.
Not seeing the little red dot there. It should be the little red,
I'm trying to make it
one with a red
advance.
line on it right above the arrows. That should be it.
I'm trying to advance this slide.
Oh, you're trying to advance
Okay.
it.
Yeah. Keep going till you see a globe with some lines on it. Keep going. Back, back, back. Anyway, the answer is yes. As we do our orbit raising, we start in the highly elliptical GTO, and then we work to circularize, and you could be let out at different points, for example, if you didn't want to, here. So you'll notice here we're starting to, the transfer orbit has low numbers, and then as we circularize, it gets higher and higher. So there's options for letting you out at different points.
Got a quick question. Maybe I missed it. How much does it cost?
Initially, and depending on, it works now. Depending on how many of these services, roughly $100,000 per kilogram, and that will
to GTO and or GEO, or is it one of the?
And it will be less to GTO, it will be more to GEO. And that's a rough price point because we need to discuss how many of these things need added in.
So if you wanted the difference between just no services, just the launch, please, when you give, and they hand you all the paperwork, and we want every service you have in the launch, what's the differential roughly, back of very roughly? Factor 2
or 3,
okay.
Abraham from Fletcher. Say we ride in the 90 kilogram payload package, but we request you to have us plugged in your power plant and do some other communication relay aggregation, that kind of services which is non-interfering with your business, but don't eject us out. Is that possible?
Yep, and that's this hosted payload that we're doing all the time now exactly that kind of thing where we host something that's completely unrelated to our mission. It stays behind and does something else like communications. Yes, that's our comfort zone.
Thank you.
Lori, my name is Adam Glickman, and I'm wondering what chemistries or fuels would be allowed to be carried. I realize it's an insurance issue for any secondary payload.
Yep.
And even though you're bolted on, you're probably seen as a secondary payload.
So
and also return capabilities, if there might be such ability.
So the first question of the propellant, we have talked to our insurance about, for example, biprop, and they acknowledge that we have 3,000 kilograms of biprop in our spacecraft. So they said, that's fine, just don't do different than what you're already doing. So the like the fueling processes at the launch base, everything is similar. So we can say propellant. I think it says on here somewhere. Yes, we can do that. Maybe this version doesn't have that. And did you have a second part to your question?
For other chemistries, say you wanted to fly just basic atoms or molecules up to space, would that be possible, or has that been done?
We'd have to talk about what specifically, like we've talked about biprop specifically, but if you have a specific example, we can look into it if you come talk to me.
Yeah, it'd be more like the organic chemistries, basically.
Yeah.
And then also, is it possible to return? Have you worked on any return back to Earth processes?
No. We go and stay there, but if you have ideas, yeah, if you have ideas, I'm open to talking about it.
Interesting. Thanks.
Great. Okay.